guys, and welcome to Mastering Hard Surface Lesson 11. We're back. Thanks for patiently waiting for me to get the Mastering V-Ray and Mastering Lighting lessons out of the way, and now that my time has been freed up again, I'm really excited to once again visit my favourite character, Iron Man. For a long time, I was obsessed with the designs created by Phil Saunders, and in my opinion, each and every Iron Man suit he's designed so far is a flawless example of sci-fi design. In fact, I love the design so much, you might consider this, insanely nerdy. I've even had Iron Man tattooed on my arm. It's hard to really say why I love the character so much, but when I originally created the Iron Man MK3 model, it helped to get my freelance career kickstarted because shortly after creating it, Marvel got in touch with me to freelance for them on an upcoming film project. Now, it's been 6 years since then, and I still admire the designs more than any other character I've seen in my life. The artwork from Phil Saunders is, I'm speechless about it pretty much every time. It's always out of control and inspirational. Now, on top of the subject matter being extremely fun, it's also a perfect challenge for hard surface modelers to tackle, as there's a really awesome combination of curvy surfaces, industrial bevels, and high frequency detail. And it allows us to model a character in a similar way to a car project, but the biggest difference here is when modeling from film projects like this, it's often the case that you don't have access to high quality blueprints or even any blueprints at all, and therefore a high attention to proportion and detail is required. So for me personally, modeling Iron Man was a huge step up in skill from cars, and I hope by breaking down how I model a character like this, you start to push your own skill set to a new level too. I've seen a lot of people attempt to model Iron Man and fail miserably, and there's been even a few people from the course attempt it, and the biggest issue is never actually the topology or the cleanliness of the model, but in the misunderstanding of his proportion and curves. So my goal is to once again explain to you the key differences that I'm focusing on while modeling, repeating the same theory that has been taught in previous lessons, but most importantly, how I'm going to break down his proportions. A project like this is extremely hard to do with a single monitor at hand also. So once again, I can't stress enough how important having detailed reference on hand at all times is essential to the workflow. I personally have 3 monitors, and while modeling anything, I always utilize the other 2 for reference. If I had my own way, I'd probably have 6 monitors all filled with reference. And honestly, you can just never have too much. So whether or not you've got things printed on paper because you don't have other monitors, just do whatever you can to cover your desk or your screens with as much reference as possible. Now, unlike previous lessons, I'm going to leave it up to you this time to find your own reference for the project, and that means tracking down and setting up the blueprints from Phil Saunders and any reference material you want. I personally relied on the Sideshow toy images as well as the blueprints created by Phil Saunders and the film model created by Josh Herman at Legacy Effects. He's probably one of the best modelers in the history of film, and even though he's a Maya artist, his attention to detail and cleanliness in his topology is pretty much perfect for film projects. So I'm going to do things a little bit differently in 3ds Max. I'm going to try and do things at a lower resolution, but we'll jump right in and get started. So before you do, make sure to do your research because a project like this requires a certain level of passion. Alright guys, to get started, as usual, I'm going to create a plane. I'm just going to convert that to an editable poly, go to the pivot, and align that to the origin. And now obviously because the vertices aren't exactly on the origin, I've got to select those and center them. I'm going to add a symmetry modifier to the mesh and then go in and assign a gold shader I've just got set up here. You can just copy those settings. So obviously the model that Josh Herman created from Legacy Effects for the film was insanely detailed, and it's got a really solid wireframe structure that would be suited for something like the high-res films. However, because I've got a little bit less time to try and break this down, and it's less about modeling the helmet and more about trying to show you the different areas in which you can utilize my techniques to minimize the topology itself, I'm going to go in and make things a little bit less detailed. But with that being said, I'm still going to incorporate all the main features of the Iron Man mesh so that when we do go into the lighting course and render it, there'll be enough there to give it the sense that it's photoreal. So the first thing I'm going to do is, on a mesh like this, and it's a little bit hard to explain at this point because everything I've explained so far requires you to understand that on an edge like this, it's good to have the topology flowing in that direction. However, at this early stage, it's not ideal to go in and add that. What we're going to do is we're going to lay out the basic topology of the helmet itself, and then on the areas where we do need those wireframe edges, I can go in and shame for some edges that we set up a little bit later in the process. So to start out, I need to actually consider how dense I want the mesh to go. And that requires studying kind of the details that are required on a mesh like this. Now, even though the faceplate is fairly low res, and I got away with making the mesh extremely low res on my MK3 model, this one has a little bit more details in it. Down here where the chin kind of blends in to the faceplate, there's a couple of little curves and stuff that I need to incorporate. You can see here it's kind of, instead of on the MK3 where it's flat, now we've got a little bit more detail. There's a couple of small bevels that you can't really see from the wireframe at this point, but in this early lesson I'm just going to not worry about those so much and try and make sure that the topology I lay out is as low as it can go while still having the ability to go in later and add those little details like the bolts and chamfered edges on some of the smaller parts. So to get started, I'm just going to line this bottom right vertice somewhere in the middle of the faceplate and drag down. And then on this vertice, what I'm going to do is drag up. So what we're essentially doing is we're kind of branching off that topology in that area. And what I can do straight away is just drag out. Now I'm going to go in and cut a line on the center of the mesh. And you can see here where the faceplate kind of sticks up that we're going to need to go in and pull that up. And if we only have one vertice in the center here, it's going to add a much higher risk of pinching. So I know early on at this stage, I'm going to go in and add a second edge loop in the center here. And when I do that, I can just maybe even this out a little bit. And in fact, I'll probably just go in and add one more. Now, because we know that these vertices on the center line are locked on the origin, I can just grab these, scale them in, and pull them in. And now you can see what I was talking about earlier is, even though that topology doesn't flow, what we're going to do later on is go in and chamfer this edge. And when I go in and connect those vertices, you can see we're converting that into an edge flow that follows along the bevel. But for now, I'm not going to worry about that because I'm just trying to block out the topology itself. So I'm going to grab the edge of the plate now and drag this back. And I'm going to drag this up to the front. And I'm actually going to flip the mesh because now I want the edges on this left side to be showing from front on. I don't want to be seeing the back side of these edge loops. So you'll notice that this early stage, I'm just using Alt X to make sure that the mesh itself is thin. And now I'll just start getting into shaping this to the actual geometry itself. And these blueprints created by Phil Saunders are going to be a lot better than the ones we used in the first lesson or one of the first lessons on the Ferrari where things didn't really line up. So you can trust a lot more because when you see Phil's work, you know, the guy's a genius when it comes to concepting, and he really has, you know, created, in my opinion, the perfect Iron Man suits. So just really early days, just lining things up. I'm just going to pull these down and keep a little bit of a flow happening from the outside mesh into here. it's going to help us a little bit later on when I go in and try and clean up this topology. I can pull this up. I'm just going to drag some edges up here. And you'll notice I don't really care so much at this early stage about making sure everything is perfectly clean and topologically correct, because I'm just trying to lay down the foundation. So one of the most important parts at this stage is understanding how wide you need to go on the mesh itself. So you can see at this early stage we're not getting a proper curvature happening from the outside of the mesh. And as you go towards the edge here, these loops are kind of very, near flat. So I need to pull them out a bit more. And that can sometimes mean going up. You can see from this edge loop, we're going to pull down and create the bevel along this side of the face. So at this point I can go in, select the edge loop along here, or the edge ring, sorry. I'm just going to connect an edge loop in between it. I'm going to do the same for down here. Every so often you'll notice I hit the C button, which, as you know by now, is the edge constraint toggle, so I can go in without changing the directionality of the sideways curve. I can go in and just kind of reshift some vertices non-destructively. And there is a little bit of roundness, even though you can see here it looks kind of flat. There's a tiny little bit of roundness that fades into that flat edge. So I'm just keeping that in mind. And I'm not just gonna, you can see as I make this totally flat, then we lose that roundness, but then it also makes it impossible to blend the curve that exists out here into that flat edge. So I'm gonna go in and add a smooth modifier to this, just to make it a little bit easier to see how the polygons are being distributed. And I can just collapse that down. And you see little inconsistencies where the wireframe doesn't flow very nicely. So as usual, you can see most of the process is basically just having the patience to go in and just push vertices around until they're in the right spot. You know, there's not really much artistic input going in here. All I'm trying to do is for each row of edge loops and edge rings, I'm just trying to create like an even distribution of polygons. So if there's anything ever down here as like an exaggerated example, you can see that it just stops the flowing. So you know, from this direction, I'm just trying to make that even. You know, from here, you can see I'm just trying to get it all fitting in. Every so often, you'll notice I just kind of go out from the perspective viewport just to take a look at how things are blending together. And what I'm going to do here is I'm going to keep the amount of geometry even, I'm just going to go in and chamfer this. And you'll notice I still haven't put a turbo smooth on this because I just want to make sure that the distribution of polygons is as low as it can be and is kind of optimized as it can be. Now eventually I'm going to need to go in and add the little bolt that exists down here. So as usual, I just need to go in and make sure I have enough geometry for that. So I'm going to chamfer these two. And now we can go in later on and split the vertices a little bit further and add that over this edge loop that we're going to create in here. But I won't create that just yet, but we'll create that bolt around this kind of 8-sided point. You can see these vertices from above, they're just sticking out. So I can just kind of select those and start pulling them in. You can see when I've moved from the front on side, I've moved that vertice back into place. What's happened is these ones are popping out now around here. So I also need to keep these in line. And that will involve pulling these in so they're not bulging out like that. Or if they are bulging out, it's just a very subtle, you know, just very, very subtle. So at this point, I'm going to go in and add a turbo smooth on, and we can start kind of cleaning up some of these areas. You'll see that once I get this main front base plate out, it'll be much easier to go in and extend from it. I just need to make sure at this early stage that the roundness is, you know, consistent with the actual real model. Because a lot of the times, modeling an Ironman suit, in my opinion, is kind of like a rite of passage for a hard surface modeler, because it's got everything a really nice, clean, hard surface model requires, you know what I mean? You've got lots of small details on a very well, evenly distributed, you know, curvy surface. So the details aren't insane. It's not like a Transformers model where it's just outrageously detailed and you lose a lot of the shape. It's kind of just more like a very advanced car model. And the biggest mistake guys make is going in and adding details before they get this original base plate correct, and then everything else from that point is impossible to clean up, you know, because you've got, you know, one surface, two surfaces, three surfaces, you know. From here, there's like another one, and to go in and re-clean that a little bit later is just too difficult. So now you can see I'm just going to start playing with the curvature here, and you'll just notice when you go from these extreme angles, every so often you just see something that just doesn't look right. So I've just got to select it, you know, and just fix it up one by one. Every so often it's a good idea to just kind of move it in an extreme fashion. I'm just going to go in and add a second turbo smooth to the mesh. You see we're getting a little pinch there. That little pinch will go away when I add a chamfer to this edge. Just making tiny little adjustments here and there. And now I can go in and select this edge and add that chamfer I was talking about earlier. When I do that, I'm just going to pull it out a bit. You can see we're still getting that pinch. So this is where I can go in and actually select both of those vertices. And if I move this, eventually it's going to hit a point where there's minimal pinching. like so. Just going to go down the bottom here and shame for this now. And there's a very subtle raise in this front area, so I'm just going to lift that up now. And then down here, I'm going to pull this in a little bit. So from underneath now, one of the problems I'm starting to notice is that the curvature we've got going here is looking a little bit lumpy. What I mean by that is you can see the front of the plate goes perfectly flat, and then from here it kind of starts fading off a little bit too quickly. So to fix that, I'm going to go in from underneath and add a slight curve to these points and pull them in a bit more. Now from here, this point isn't going flat like it was like this. We've got a bit more of a curvature and it's flowing more into the side of the plate. Just going to select these outside vertices and just rotate them up. I'm going to have to turn off sometimes angle snaps on, and just remember that when you have angle snap on, sometimes you lose some of that finer control. The reason I'm doing this is because I've noticed on the reference image that in this concept art, the plate probably goes out a little bit too far wide. You know, the angle's sitting a bit too much like that, and I've just got to correct that. So I'm just going to pull that in. Same goes for this piece. I can just pull this in like so. This bit is a little bit too high. You notice there's just a very slight dint in the center here. So I'm going to go from underneath and just very slightly correct that. Now these are a bit even. You can see this side is a little bit smaller than this side. So I'm just going to turn on edge snap, move those in. can see what's happening here is now we've added that chamfer, you lose some of the, consistency on that edge. And to fix that, I'm just going in and it's all these subtle details that make up that perfectly smooth mesh that you're kind of looking for. If you don't go in and pay attention to little things like that, you're going to get little pinches. So I really can't stress enough the importance of trying to find those angles which show off the imperfections in the mesh. That's what it's all about, When you've got a mesh that's actually not so detailed but has a very consistent and clean curve to it, you're not going to be able to get away with it just kind of modeling from front and side on. That's how you end up with those really lopsided meshes that don't have the correct proportions. So on the front here, it's still just not rounding correctly. Just going to pull all these vertices out a little bit. I'm just going from above. It's probably a little bit surprising for a few of you just how much you need to push these vertices around until they're in the right place. But like I can't stress enough, it's it's just the most critical part of the model. Everything else is going to flow off this one set of edge loops. So you can see I've turned on edge constraint here. I'm just sliding that edge loop so we've got it flowing up into this next bit up the top here. And that means I'm also going to need to pull down on this area here. So I'm fairly confident now that the curvature is working well enough where, I can see it's not perfect, but what I'm going to do now is because sometimes you get a little bit caught up in trying to perfect something before you've got another frame of reference. So it's kind of trying to balance out at what point you continue on in the model. I mean, you can see here there's some weird shapes going on in terms of the curvature this way. So I'm just going to, just before I go in, I'm just going to fix that. And you can see I need to pull this out. Okay, now what I'm going to do is I'm going to extend this side piece here. And to do that, I'm going to select the edge loop. I'm going to hold Shift and drag it down. And you can see what that does is it creates a kind of a little bit more of an even surface. So rather than going in and dragging out like this and then kind of positioning them, by using the scale feature and then dragging it out, you have the option to keep some of that consistency in how this curve flows into the outer side of the plate.